Hello guys, Assalamualaikum and a very good morning. So again, I would like to introduce you Dr. Amirul Aizat. So, he would like to do an experiment to study the mechanism of the lithium. Either it will be lithiation or de-lithiation. So can you explain a little bit about your procedure in terms of what application and brief description about this analysis?
Okay, so this is we run for cyclic voltammetry,
Okay.
and then we will study the movement of lithium, whether it is lithiation or de-lithiation, using cyclic voltammetry. Okay, so from here, from this analysis, what we actually study, we want to know which potential. Okay, for example, we have like specific materials. We want to know which potential actually happen the lithiation and de-lithiation. Okay, for example, okay, the easiest example is like graphite material. Okay, so we know that the lithiation for graphite is actually occur at around 0.1 volt. Okay, so for other materials, for those who study different materials, so they need to find some literatures which peak actually undergo oxidation and reduction. Yeah, so that's the easiest explanation for this analysis.
Okay, so to sum up what I understand, you said that if we have two material, for example, carbon-based material and metal oxide,
Yes.
each material have their unique potential at where the potential occur lithiation and de-lithiation. Is it correct?
Yes. It's quite the same as supercapacitor, but supercapacitor is mostly we run CV to check the area and to get the current response. But for this one, mainly is that we want to study the mechanism, the movement of lithium ion from to our electrode and outside outside from our electrode. Yeah.
So what is the indicator to see the lithiation or de-lithiation happen? Is it the redox peak or what?
Yes. So for half cell, we have half cell and full cell. So but this one I focus on half cell. So half cell, normally we will go discharge, which is we undergo reduction first. Okay. So here you can see when we undergo reduction, so from positive to negative potential, so you can see there's a peak here. Okay, it's a very small peak, but sometimes we can see very obvious peak like this one. Okay, so this one actually represent the lithiation.
That one is cathodic peak, right?
Yes, cathodic peak. So for half cell, cathodic peak and cathodic peak is actually represent the lithiation, and for the anodic peak is actually opposite, which is de-lithiation.
Wow, yes. Very interesting, Dr. Amirul. Can you show the setup? We want to see the setup.
So basically you have your coin cell, okay? And then we need to have
coin cell holder.
Yes, coin cell holder. So we just connect based on the terminal. Okay. So for positive, you need to connect with the working electrode, and opposite side is actually negative, will be with the
This one, the positive is lithium metal?
No, positive is actually our electrode.
The negative
is the lithium metal, pure lithium metal.
Okay. Alright. So you put electrolyte and so on.
Okay,
so
so
we're going to
then
run.
you need to check. You need to set the voltage range. Okay, based on your materials. Okay, which potential that they will undergo redox, and then find a very suitable scan rate. Okay, because when you go very high scan rate, basically you cannot get a very obvious peak. Okay.
Okay,
so
at low scan rate.
Yeah, I will recommend to use very low scan rate. For example, like 0.1 millivolt per second.
Oh.
Okay, very low.
Very slow.
But you can see very clearly which actually peak represent the lithiation and de-lithiation. Okay.
Oh, for potential window, we need to set very big. For example, here you set until 3, but your material only
no
2.
Okay, no. Okay, because this one, okay, this actually represent our initial voltage.
Okay.
Before we run anything. So actually our initial voltage for example here is around 2.95. Okay, so from this setup we will start from our OCV.
Okay.
You see here?
Yes.
So it will based on the OCV. So it will run from our OCV, go to lowest voltage, and then it will follow the step. Okay. Right. Okay.
Okay, thank you very much. Hope your experiment is successful.
Thank you.
Okay, bye.